Hi everyone, this video is designed to talk about vertex form of quadratic functions. This form is the one you are by far the most familiar with because you worked with it in chapter 3. A quick review, y equals x squared is the parent graph for a parabola, the quadratic functions. Vertex form y equals a times the quantity of x minus h squared plus k. If you recall, the vertex is h comma k, and the a gives you your stretch. So think of it as the k moves the vertex of the parabola up or down, the h moves it to the left or to the right. If we review where we are in this chapter or in this lesson, vertex form is one of the 3 forms of quadratic functions. Remember, quadratic functions have a lot of information to tell us. So we have 3 different forms to talk about it, each kind of emphasizing different things that are important. And now let's quickly review how to graph from vertex form. If you look at this example, this is all things you've learned back in chapter 3. We have vertex form of a function right here. Y equals quantity of x minus 2 squared minus 5. That puts our vertex at 2 comma 5. Axis of symmetry, that is the only thing new. I'll come back to that. If you can recall that this parabola will open up because our a value is positive. A actually equals 1 here. And our pattern of change is always 1a, 3a, 5a. And since a is 1, we know from our vertex of 2, negative 5, we will go up 1 to the right 1, up 3 to the right 1, and up 5 to the right 1. And we'll do the same on the left. Up 1 to the left 1, up 3 to the left 1, up 5 to the left 1. So the only thing new to talk about is the idea of an axis of symmetry. In this problem, the axis of symmetry is at x equals 2. If I draw that in, x equals 2 is a vertical line. And if you thought of this as symmetry, if you folded your paper, did a horizontal reflection at that line, the parabolas would, the points on the parabola would meet up. This would meet up with this one. This point would meet up here. This point would meet up there. So your axis of symmetry is always going to be, for these parabolas, a vertical line, so x equals, and notice that x equals 2, that matches with the x value of your vertex. Oops, shoot, I thought that was a highlighter. The x value of your vertex and the x equals 2 in the axis of symmetry will match up. If you need to pause this to write any more down, please go ahead. The next example is already almost all the way done for us as well. You can see we have vertex form right here. Our vertex is at a negative 1 comma 7, which we have marked on our graph. It will open down because the a value is negative. It's a negative 2. And that puts the pattern of change at 1a, 3a, 5a. So you'll have a 1 times negative 2, 3 times negative 2, and 5 times negative 2. So we get our pattern of change of negative 2, negative 6, and negative 10. So that's why from the vertex, I went down 2 to the right 1, down 6 to the right 1. Sorry about that. And then I would go down 10 to the right 1. And same on the other side. So the only thing new is that axis of symmetry again of x equals negative 1. Please notice that the x value of the vertex and the axis of symmetry match. And if you were going to sketch that on your graph, it'd be a vertical line. It cuts through the vertex and cuts your parabola in half. And then the last thing that I didn't do is try to draw my parabola. Keep in mind to try to do a nice curve down here. It shouldn't look like a V, it should look like a curve. And then it's going to go down and out forever in both directions. I'm going to try to put some decent arrows on there. Do your best when you draw these to not have your parabolas curve back in on themselves. I see a lot of students kind of drawing like that and like that. That's not a parabola. It should be going down and out. That domain is negative infinity to positive infinity. From left to right, it will go on forever. So there's a quick review on vertex form. Thanks.